Hello, everyone. So on to the next exciting panel. And while the previous panel was looking at the, how AI, ML, Edge, and 5G are coming together, especially focusing on the industrial IoT applications, this panel takes us to a different problem and a different, really, really important problem. I'll give you a quick background, and this is where, RF Check and us started discussing. I was giving a seminar at NASM, National Academy of Science, Engineering and Medicine. And I feel the top question was, or the question that was, most in people's minds was, what about safety? You guys are talking about 5G. 5G will be omnipresent. There'll be densification of cells. The 5G will be there inside our buildings. What do you think of safety? And these questions are out of real concern. Yes, there have been other kinds of fake news kind of things about RF safety coming out of UK, that 5G is responsible for coronavirus. But if you forget about all that noise, I have been brought into media discussions, interviewed by local TV channels about RF safety of 4G and also the coming of 5G. So there's a lot of concern about what would be what will the future networks do to our safety. So this panel is very, very timely, and I would like to very, very quickly introduce Gilbert Amelio. Gil, it's a real honor for us to be able to have you here. Gil is quite a legend. Gil is the chairman of the board at RF Check, but Gil has been the CEO and chairman of Apple Computer. Gil has been the president, CEO, and chairman of National Semiconductor, president of Rockwell Communication Systems. So the list goes on and on. And so it's a real, real honor, Gil, to have you here and moderate and chair this session. Thank you. Floor to you. Gil, you are mute. If you can unmute yourself.
Okay, can you hear me now?
Yes.
Great, thank you. Well, let me just add slightly to my background. I have a PhD in physics from Georgia Tech, and after I graduated, I went to Bell Laboratories as a research scientist. I was one of the co-inventors of the world's first solid-state image sensor, which all of you use every day in your iPhones and other applications. And then I journeyed to Silicon Valley and spent many years there helping build Silicon Valley, and I've been recognized as one of the 50 pioneers that built Silicon Valley. Somewhere during all of that time, I also served on the board of AT&T for 18 years. So I really know a lot about telecommunications, and I'm thrilled to be able to host this panel. Our panelists today are a very distinguished group. We have with us today Bob Cleveland, Daniel Harigi, Dennis McCall, and Jinyu Zhang. I'm going to let each of them introduce themselves briefly, starting with Bob Cleveland. Bob?
Thank you, Gil. Yes, just in a way of background, my educational background is in physics and biophysics. I've been involved in research and teaching and radiation biology, physics, biophysics, microbiology also. And I worked at the FCC, the U.S. Federal Communications Commission, for 27 years in the Office of Engineering and Technology. I retired from there in 2007, and I was responsible at the FCC for coordinating FCC policy related to human exposure to radio frequency energy. And now I'm an independent consultant specializing in RF safety. That's about it.
Okay, Daniel?
Okay, I'll go. I'm Daniel Harigi. I'm the president of RF Check, now known as Safe Dynamics. I started in wireless back in 1990 as a microwave engineer for a company called Pactel Cellular here in San Diego. And one of my first projects was to put in place a safety program for our field technicians, where we issued them these small NARDA alert RF safety monitors. And a few years later, after that, as a PE, some of the places around here, cities like Escondido and Del Mar, started requiring RF safety studies. So I would prepare those and submit those to these communities to show that the cell sites that we were building in their neighborhoods were safe. Had a few roles since then, but funny because 25 years later, here I am back again in the field of RF safety. So, thank you.
Thanks, Daniel. Dennis?
Hi, everybody. Is my audio okay? Oh,
Yes.
Yep.
great. I am an associate fellow of technology with Verizon Communications headquarters, specializing in RF systems. I've been with the company for 26 years, and in that scope, I've worked on performance. I've built sites. I've dealt with interference and electromagnetic emission standards and issues, and I'm very interested. Have been interested in it for a couple of decades. So it's a pleasure to be here with Robert Cleveland, the guy that was on the group that wrote OET 65. It's an honor, and I'm happy to participate in this discussion just so that we can bring forth the ideas and search for the truth and get the answers that will be useful.
Thank you, Dennis. Junyu?
Hello, everyone. This is Shenyu Zhang. I'm a faculty member with the EC department at UCSD. I joined the UCSD in 2017. Before then, I was a faculty member with UW-Madison. My research mainly focuses on wireless systems and mobile computing. I have been working on the next generations of wireless networks, in particular millimeter wave networks. And my focus is mainly on the high layer network algorithm and protocol design, such as millimeter wave beam management, V2X, interference management, etc. My research is experiment driven. I build a lot of prototypes and experimental testbeds, including millimeter wave software radios and also some microwave band artifacts. Besides networking, I also work actively on RF sensing, mostly using the radio devices themselves as sensors. For example, using the millimeter wave radios and also Wi-Fi radios to sense health or physiological status of human, to sense activity and location, to enable some new ubiquitous computing applications such as human-computer interaction, mobile health, etc. I'm glad to join this panel and share my thoughts. Thank you.
Thank you very much, Junyu. Let me start with a question for Daniel. Why is RF safety important? What do we need to do? What do we need to worry about? What should we be doing about RF safety?
Okay, so it's really pretty simple. The federal government has established regulations that limit the amount of human exposure to RF. And clearly there's a reason for those regulations, right? So just like with the speed limit, without these laws, there's potential for harm. But as long as we follow the laws, and in our case, as long as we're compliant with those regulations set by the FCC, then we should be safe.
Let's move on to Bob. What are the current standards, and are they appropriate for where we are today as this technology evolves all the time?
Well, I actually have prepared some slides, and I think I'll just go through those sort of quickly, and then we can, discuss them if that's okay. I guess I'm going to share my screen now, correct? Let me try that.
Hopefully they can put it up. There you go.
Okay. So I'm going to start the slideshow here. Okay. All right, can everybody see that all right? Okay, and you can hear me okay?
Yes.
Okay. All right, so we're talking about human exposure, and we have two categories basically, exposure to the public and exposure workers. And both of those have their own separate issues that I'll talk about. And there are lots of sources in the environment. Wireless base stations. Obviously, that's the one of the main things we're talking about. Also, in the past, we've had a lot of issues related to radio and television broadcast antennas. There are some sites around the country that have high density and high powered radio and television broadcast. For example, above LA, you have Mount Wilson. If you've ever been up there, you've seen, lots of antennas, and mostly those are pretty well controlled right now. But in the past, that hasn't always been the case. And there are also a lot of sites that have multiple antennas from various wireless companies and other vendors and companies. So they have to be evaluated for safety to make sure we're not overexposing people. And then sometimes we have tower climbers that have to go up and work on antennas. That's another source of exposure. And for the public, there are lots of devices out there. And of course, we have 5G coming, and we have smartphones and laptops, Wi-Fi, two-way radios, and all that. So these are the primary organizations that are involved in developing exposure standards and methods of evaluation. The IEEE has a committee, the International Committee on Electromagnetic Safety, ISIS, which I'm involved in, and Daniel has been involved in. And it's an ongoing committee that develops a lot of information on standards and a standard, and also other documents related to evaluating exposure. Then the International Commission on Non-Ionizing Radiation Protection, ICNIRP, is an international organization. A lot of countries use their standard. And then in the United States, we have the National Council on Radiation Protection and Measurements, which has been active in the non-ionizing radio frequency area before. They're not too active at the moment, however. And then the International Electrotechnical Commission develops primarily methodologies for evaluating things like devices, handheld devices, and so forth. This is the cover sheet for the latest IEEE standard that came out last year for safety levels with respect to human exposure from 0 hertz all the way up to 300 gigahertz. And then in 2020, also very recently, ICNIRP came out with this new set of guidelines, and you can access that in the journal Health Physics. So the basis for all these exposure limits is a quantity we call specific absorption rate. And not to go into too much detail, but basically we have 2 tiers of exposure for most of these exposure limits. One is for the workers, occupational, one is for the population, general population. And you'll notice here, there are safety factors of 10 for workers and 50 for the public. Now, partial body guidelines for things like mobile phones are derived from dosimetry considerations. And in the United States, we have a mobile phone limit of 1.6 watts per kilogram. That's specific absorption rate. That's based on the 1991 IEEE recommendation. The FCC rules are found, the FCC rules are found in Title 47 of the Code of Federal Regulations, CFR, and this just tells you something about that. The basis for the FCC responsibility here is the National Environmental Policy Act, or NEPA, which requires all federal agencies to evaluate the environmental impact of their actions. And in the case of the FCC, the primary environmental action is the licensing of devices and transmitters that could expose people to environmental levels of radio frequency energy. So these are just the rule sections that deal with that. The current guidelines out from the FCC are based on the 1986 NCRP recommendations and the 1991 IEEE guidelines. And these were adopted in 1996, and they're still in effect today. The other thing that people should know is that the FCC is not a health and safety agency, and so it relies on expert guidance and advice from these other federal agencies, which are experts in health and safety. The FDA, the EPA, NIOSH, and OSHA. Was that the question? No, okay. There actually has been a coordinating group set up, an interagency working group, to work with the FCC on developing guidelines. So anyway, as I mentioned before, we have two tiers of exposure. One is for workers, the less restrictive upper tier, and the most restrictive lower tier is for the general public and you know, the general population. Not to go into this in much detail, we don't have enough time, but basically these are the limits. You'll see they're broken down by frequency. The upper tier is A, the lower tier is B. The limits are given in terms of various quantities, including electric field strength, magnetic field strength, power density, and also averaging time. This is a graphic representation of the limits. The upper tier is the solid line, and the lower tier is the dotted line. And you'll see frequency range is 0.3 megahertz up to 100 gigahertz. Okay, now there's a lot going on at the FCC right now related to this issue. There was a release document December of 2019, FCC 19-126. It's a very important document. It's over 150 pages long. There's a lot of sections here, which I'll just briefly summarize. But this was a resolution of a notice of inquiry. It included a second report and order, a notice of proposed rulemaking, and a memorandum, opinion, and order. So there are actually four parts of this document. The notice of inquiry had been dealing with whether the FCC should revise its actual exposure standards. And after an extensive review of the comments received and the record over a period of 6 years, actually, because it was issued in 2013, they decided that they were not going to revise the exposure standards, and so they were going to keep the ones in place that were in place since 1996. And there's a statement in their discussion that their decision is supported by the FCC's expert safety agencies, including the FDA. And you can download that document from the FCC website and look at it in more detail. Then the two other parts that are most important are the second report and order, which was the termination of a docket that was open in 2003, believe it or not. It's taken 17 years to get to this point. And it has several important parts, which I'm just going to mention here briefly. It adopts exemption criteria for routine evaluation based on power levels, SAR, what we call maximum permissible exposure, MPE. It adopted policies for how to deal with multiple source environments. Policies were adopted for computational and other methodologies for evaluating compliance, and policies on mitigation methods to ensure compliance, and policies on access control for workers, training requirements for workers, and so forth, and licensee responsibility for mitigating exposure. So all these were part of the second report and order. The other important part of the document is the ET docket 19226, which is a new docket, and it's a notice of proposed rulemaking. And this is probably fairly relevant to 5G because this docket addresses new technologies, especially in the millimeter wave range. It's seeking comment on what kind of localized exposure limits should be used above 6 gigahertz. It proposes extending the existing power density limits for millimeter waves all the way up to 3 terahertz, 3,000 gigahertz. And it seeks comments on how to time average and average an area for evaluating exposure for compliance of wireless devices such as those that might be held close to the body. There are also issues related to wireless power transfer, which is not a communication issue, but it is an up-and-coming technology up in the millimeter wave range. So that's sort of a quick rundown of the main topics of this new docket, and I can answer questions about it later if you have any. Okay, that's it. Thank you.
Any questions? We still have the screen up here. Did you release your screen, Bob?
Oh yeah, let me close this. Okay.
Thank you. Thank you. Okay. Dennis, let me ask you this. What are the challenges we're going to face in complying with this? How do we get the public informed yet comfortable with all the things the industry is doing to proliferate this wonderful technology, but keeping it safe at the same time?
Right. Well, from a service provider point of view, it's the magnitude of keeping thousands of cell sites compliant with guidelines, well, not guidelines, with rules and regulations is daunting. So we take a very conservative, very simple approach. We assume if we're going to model, of course, we're going to model and not measure. And there's a question from Roger Nichols regarding measuring massive MIMO in all of these intricate areas. Measuring sites is just way too complex. You can't guarantee that a site is at full power when you're making the measurement and trying to find the maximum gain from a massive MIMO antenna. It's not realistic, and it presents some uncertainty. So from the public's point of view, I want to give them a certainty that yes, we are within our rules and regulations, and that we are going to calculate. We're going to model the worst case scenarios or worst case assumptions. Right, full power. We're going to add a ground reflection. We're going to choose the maximum gain that is present, and we're going to assume that all the power that the radio can deliver is delivering that in that space. And then we're going to make sure that we're going to make sure that sites are intrinsically compliant, meaning we're building sites at the edge of buildings where people can't get in front of unless you're a window washer, and we deal with that. Or if they're on towers and people can't approach the antennas, that's the best solution. Make sure that you're building sites where people can't get near. But in some cases you do, and you have to mitigate that. And so we have rules and processes and procedures that we stay on top of to make sure that we are not getting close to our limits. And with respect to the public, I would encourage them to read the rules, understand where they come from, because I personally am very comfortable that the safety factors that are in place and the spatial averaging and time averaging requirements give us a situation where ideally we never have a situation where somebody can get in a spot and exceed the rules. And I would emphasize that from a service provider's point of view, we don't make up the rules. We live by the rules, and we allow the responsible agencies to determine what those rules should be.
Okay, thank you very much, Dennis. Jinyu, what work's being done at the university on the topics we're discussing today? Can you share some of that with us?
Sure. First of all, recently we have started collaborating with RF-Check Daniel's team to setting up some experimental platform, including actual millimeter wave testbeds and also 3D ray tracing simulator to study the RF exposure and the safety issue of 5G base stations. So our goal is to provide some quantitative understanding and review the potentially hidden problem of RF safety, especially related with the millimeter wave, which is going to be widely deployed. And the problem itself, I think it's important, not just because of safety itself, but because we really need some education of the general public about this RF safety. I think this is also the same education is perhaps needed for people with technical background, because I recall a few years ago when I attended a workshop, one of the EC professors warned me about millimeter wave, saying that it's going to burn your eyes. So I think this reveals how important this problem is, and we need to really study this and make it known or clarify the problem for the general people.
Thank you, Jin. So final question for anyone on the panel is: are the deployments that are going on right now safe? Is there any reason for the public to be concerned about what's happening right now as we deploy 5G, not only in this country but around the world? Anyone?
So I think first we definitely have to discriminate between 5G as a protocol and millimeter wave, because just like we took amps and took it to 2G and we took it to 3G, and all of the frequencies that every service provider has is going to evolve from 1G to another G. And in about 2025, we're going to have 6G. And these are just different languages that are being spoken on the same spectrum. No difference. So we have sub 6 gigahertz licensed spectrum that will be 5G, and then there's millimeter wave. So I think I believe that there's more concern about millimeter wave. And in respect to that, I mean, it's not, in my view, it's not that much different than 6 gigahertz. I mean, the antennas get smaller, but the effects are characterized in the same limits we've been using for 30 years. So I trust that the limits that we have are safe, and we certainly would comply with them.
Okay, anyone else? Comments? Okay. Well,
I'll just say that there have been places around the country where the FCC has gone in and found that there need to be changes. There's no question about that. You can actually look at some of the enforcement actions that have been taken by the FCC related to complicated sites where you might have a lot of different types of transmitters. So there has been action taken by the FCC, and there are companies out there, as most of you know, that specialize in evaluating compliance. So it's not like, we don't need to look into this. Especially, I think the most common exposure is going to be to workers, not necessarily the public. If you have some of these really complicated rooftop sites, for example, where you might have people up there cleaning the rooftop or window washers, things like that, those people need to be properly informed of their exposure. And FCC in this latest docket is talking about the specific training required for people to be exposed and what information has to be given to them and so forth. And Daniel's company is working on these projects, as he already talked about. So,
Right.
I think the only thing I'd add is, from what we know today, I think it's fair to say that the technology is safe. 5G technology even is safe. But that's with the caveat that it's operating and it's in compliance with the existing regulations, right? So as long as these sites are in compliance, then I think we can say that they are safe.
okay. How about let's opening the floor for questions from the audience. Are there any questions from our viewers?
I'll take them, Gil. I opened up the Q&A here. There's a question from Roger Nichols. Basically, the industry has probably not done enough to tear apart some of these myths about 5G or the technology and really what the true story is. And maybe even the industry itself is doing a disservice. And what are some things that we as an industry can do to help with this, help get some of this information out? And so that really, for us, and along with our partners at UCSD, this is something that was the intent of this RF safety study. A lot of you probably remember, go back in time about 10 years or so when we were rolling out a lot of smart meters, right? And there was a big outcry from this part of the public that said smart meters were dangerous. They're putting this in my house and it's really close to my bedroom, and all kinds of bad things are going to happen. And so there was a big movement against the deployment of smart meters, which were actually a very technologically good thing with a lot of different benefits. So what happened there? Well, EPRI, which is the Electrical Power Research Institute, came out. They did a study with one of the acknowledged experts, one of Bob's colleagues, Rick Tell, and they put out this report with empirical data, real data. They set up the exact configurations that people would have in their homes. They took the worst case assumptions like Dennis talked about, and they took actual measurements, and they collected this empirical data, and they produced this report. And now they have scientific, real data that they could show to the public. And of course, it came from EPRI, so people would criticize that a little bit because it was from an industry source. But then on top of that, organizations like the CCST, which is the California Coalition of Science and Technology, adopted that report, and now basically sanctioned it and told the public that, okay, this is our position on it. We're an independent body, and we believe, based on on this study and this data, that this technology is safe. And I think that's the same type of thing that we can do as an industry with technologies, new technologies like 5G, is to produce this kind of data and information for the public to show them that this technology can be safe.
Any other comments from the panelists?
I see another question here that I was going to comment on from Mr. Anton Monk. He's asking about the basis of the standards, and they're based on thermal effects. I would just say both the IEEE and ICNIRP just released these new standards, and both of those organizations did an extensive review of the scientific literature and came to the conclusion that these millimeter wave limits are going to be protective enough for the public and for workers. And yes, thermal effects are the only proven effects that have been judged to be potentially hazardous. These organizations have not come to the conclusion that so-called non-thermal effects, which are reported in some parts of the literature, they have not come to the conclusion that these are proven hazardous effects. So the limits that IEEE and ICNIRP both have adopted are based on proven weight of evidence, scientifically supported thermal effects on the body. And as has been mentioned before, there are safety factors, extensive safety factors built into those limits, 10 times for the workers and 50 times for members of the public.
Thanks, Bob. Well, for all of you panelists, thank you for your insights into this very important topic, one that
there are some questions in the chat, and so our board members who we have promoted to panel status, but we realize that people who are panelists cannot ask questions on Q&A, so they are asking questions on chat. But Colin, and I see Don, can you just ask the question? Can you unmute yourself and ask the question?
Yes, the 28 gigahertz SAR measurements in a Phantom with the little antennas are the, let's say, prototype smartphones with those 4-element antennas in each of the corner. Are they passing by a huge margin? I just wonder, is it a problem at 28 gigahertz, or is it easy peasy lemon squeezy to pass these levels here with the smart antennas at the 28 gigahertz power levels for 5G?
Well, I'll just comment. The FCC laboratory has a knowledge database. It's abbreviated the KDB, and they provide information to manufacturers on how to evaluate these new millimeter wave exposures. And I think that work is sort of still developing. The KDB for the high frequencies is still somewhat under development, but there are techniques for doing that. And of course, when you're talking about 28 gigahertz, you're measuring power density. You're not measuring specific absorption rate. So those devices would have to be evaluated for power density. I haven't been talking to anybody at the FCC lab about exactly how that's being done. I don't know if Dennis knows anything about manufacturers and what they're doing these days with respect to that. I know that there are companies that are developing very competent techniques for evaluating millimeter wave devices, such as the SPEAG group in Switzerland, but I don't really know too much more about it than that.
Right, but we can, based on history, we know that if somebody's manufacturing a phone, they want it to perform better than the other guy, and so they tend to skirt the limits, but they are within the limits. And so I think that with 28 gig, given it's already inside the OET 65 parameters, it's going to have to comply with the safety rules that are in effect for everything else. But knowing that companies are competing, my guess would be that yes, they're going to approach that limit, but with the assumption that it's going to be 100% duty cycle and active all the time. And so we know that the duty cycle isn't going to be 100%, and it's not going to be active all the time. So the safety factors are in play are actually going to be leveraged by the real world levels. And there was another question by I think it was Roger Nichols regarding the use of worst case assumptions. And from a service provider, I need to simplify the control of mitigating thousands of sites. And yes, it does hamper where I can put sites and how I can deploy sites, and that's okay. I would rather have that than have to deal with all of these sites every day. It's just insurmountable. But for the case of, let's say, Rick Tell's study on smart meters, where they made the worst case assumptions, it's important to do that in these studies so that people don't delegitimize it. It's like, well, you assumed it wasn't going to be full power and it can. It's like, no, we need to be credible, so we use the worst case scenarios. But you're right, we also measure, and we know that the measurements that are performed in the field, you can never find the worst case scenario. They are always under what we model. That's why I like modeling. It's I deal with the problem once and I walk away. And that means as a company, we don't have to expend overhead associated with maintaining those nightmare problems.
Very good, Dennis. Thank you.
I'm sorry, Gil. I was watching the chat, and Colin, you had a question. Can you unmute yourself and ask the question?
Thanks. I think Robert covered the first part of my question, that the limits are strictly thermal, but just any other comment on what level of confidence or if there's any ambiguity behind the thermal limits? I'd just be curious to know. Thanks.
Well, as I said before, their safety factors are built in. Now, since 1991 or earlier, the level in terms of specific absorption rate that's considered to be hazardous was 4 watts per kilogram. That's SAR. And then the safety factors were put in place, factor 10 for workers and factor 50 for the public, to take into account uncertainty. That means biological uncertainty as well as measurement uncertainty. So for years, that has been the norm. And, the FCC just made this decision that they weren't going to revise their limits, either making them stricter or actually relaxing them, which was also a proposal. so that there is confidence out there that yes, these are protective enough. Now, if you go on the internet, and there are a lot of organizations that would disagree with that statement, you can use your own judgment about that. But I would just say that these major two organizations, ICNIRP and IEEE, have done extensive reviews of the literature and have come to the conclusion that we have these limits as being protective enough.
Thank you, Bob. Other comments or questions from the audience? Well, hearing none, I want to thank the panel for their participation in this project. I think this was extremely well done. I think we've added a lot of clarity to this topic. But those of you who have more questions, please feel free to contact the CWC and keep up to date on all the work that's going on there at the university. With that, I thank all of you for attending, and it is adjourned at this time. Thank you very much. Bye-bye.
Thanks, Gil. Thanks, everybody.
Thank you, Gil, and thanks to the panelists. Excellent panel, very timely panel, as I said. And also, we look forward to the collaboration between RFCheck and UCSD. And also, I know that many of our member companies are also very interested in this topic. So thanks.
Thank you. Bye-bye now.
Thanks.